Welcome to the Hornet School, Lesson 2, Angle of Attack and Landing Basics. Lecture Intent. To understand the basics of aircraft angle of attack, learn the principles and intent of on-speed AoA in the FA-18C and how to establish it, internalize the parameters and procedures of basic straight-in landings in addition to how to solve common problems. Part 1, Angle of Attack. What is it? Why does it matter, and how do we achieve it? What is angle of attack, or AoA? The angular difference between your aircraft's pitch, where your aircraft is pointing, and its travel path, or velocity vector. Why is AoA important? General answer, your aircraft essentially always has a non-zero AoA. A large angle of attack at low air speeds produces the same amount of lift as a lower angle of attack at higher air speeds. If your AoA becomes too high, your aircraft will aerodynamically stall, i.e., the wing will no longer be able to produce enough lift to keep you in the air. One of the major strengths of the FA-18C is its superior AoA capability, which can exceed greater than 50 degrees in some circumstances. On a more practical level, it is useful to fly a specific AoA when we land. Too little AoA, and we will become nose heavy. Too much AoA, and we will tail strike. An ideal AoA during landing will have us touch down rear wheels first with a descent rate that will not damage the aircraft. On-speed angle of attack. In the FA-18C, that ideal angle of attack for landing is 8.1 degrees. This is referred to as flying on-speed AoA. Simply stated, this is the optimum orientation of the aircraft to catch an arresting wire when flying a 3.5 degree glide slope at the carrier, but we use this approach at the airfield as well. AoA indicators. You have the AoA indexer on the left side of your HUD, and inside the HUD display, you have the E bracket that will appear when the landing gear is lowered. You can see visually, slow is represented by an upside down green arrow. Slightly slow, and you'll see the meatball and the green arrow. On speed, you will only see the yellow meatball. Slightly fast, and you will have an upward pointing red arrow with the meatball. And if you're fast, you'll have just the red arrow. Trimming an aircraft is the process of adjusting its control surfaces to maintain a specific attitude without the pilot having to constantly apply that force. In the FA-18C, we adjust this with the trim hat. Back is nose up, forward is nose down, left is left wing down, right is right wing down. You will need to bind these in DCS. The FA-18C is a fly-by-wire plane, which effectively places a flight control system, or FCS, between your control inputs and the aircraft's control outputs. The configuration of the FA-18C determines how the FCS applies trim. With wheels up, adjusting trim applies a constant deflection pressure to a particular control surface. With wheels down, adjusting trim will cause the FCS to attempt to establish and maintain a particular AoA. Establishing on-speed AoA. Decrease airspeed to below 250 knots and deploy landing gear. The E bracket will appear on the HUD, and the AoA index will illuminate once the gear are lowered. The flight control system is now in approach mode, and inputs on the trim hat will cause it to attempt to establish and hold a specific AoA. Allow speed to continue to decrease below 200 knots and set flaps to full. Note, you can also set flaps to full at the same time you deploy your landing gear. The FCS will not allow the flaps to reach full deflection until your speed is sufficiently low. Depending on your speed, it is possible that aircraft will begin to suddenly gain altitude, or balloon, when the flaps are deployed. You can counter this with some forward stick input until the aircraft holds level flight with neutral stick input. Apply pitch trim as necessary to center the velocity vector within the E-bracket. If the velocity vector is below the E-bracket, apply nose-up trim or pull backward on the trim hat. If the velocity vector is above the E-bracket, apply nose-down trim, push forward on the trim hat. Control altitude whilst established on-speed AoA by increasing or decreasing throttle. If you are losing altitude, increase your throttle. If you are gaining altitude, decrease your throttle. Maneuvering in on-speed AoA, changing altitude. Once the FA-18C is trimmed for a particular AoA, any pitch inputs on the stick will cause a deviation from that AoA, which the flight control system will then attempt to correct when the pitch input is returned to neutral. The rule, do not provide pitch inputs on the stick once on-speed AoA has been established. Doing so will effectively result in a battle between you and the flight control system. Ascending or descending during on-speed AoA is accomplished by increasing or decreasing throttle, respectively. Maneuvering in on-speed AoA, changing directions. Once the FA-18C is trimmed for a particular AoA, changing direction is accomplished by adding roll, i.e. increasing bank angle. The rule: recognize that your lift vector is going to change with your bank angle. To maintain your altitude, you will need to adjust your throttle as you enter a turn and subsequently roll back to wings level. Maneuvering in on-speed AoA, changing direction. Increasing bank angle without increasing throttle will cause you to lose lift in the vertical direction. Since this is the direction of gravitational acceleration, your aircraft will begin to lose altitude. You can counter this by adding throttle and thus increasing speed or lift. Decreasing bank angle without decreasing throttle will cause you to gain lift in the vertical direction. Since it's the direction of gravitational acceleration, your aircraft will begin to gain altitude. You can counter this by decreasing throttle and thus decreasing speed or lift. Part 2. Airfield landing procedures. General parameters. Maximum landing weight, 39,000 pounds. Use the supplemental checklist page on the DDI to verify actual aircraft gross weight. Maximum vertical descent speed at touchdown, negative 750 feet per minute. Straight-in landing procedure. On-speed AoA, manage runway lineup with the roll, manage descent with throttle, put your velocity vector where you want to land, check descent rate, and adjust as needed. The descent rate in this case is much too high. We're seeing it at 1,440 feet per minute. We will break our landing gear at this descent rate. So what can we do? Managing the glide slope, how not to break your gear. Two options: increasing power to decrease the glide slope and land further down the runway. Temporarily decrease power to steepen the glide slope and descend, then we reapply power to reestablish a shallower glide slope from a lower altitude. And that's it for Lesson 2. Click on the link below or the link on the right-hand side of your screen to take you to the mentor ride-along for this portion of the lecture. Thanks for watching.